The Leave Plan of Room specialist has found that using our new 101 billion toy, it will be clearly, everlastingly, before that endeavor changes into a reality. On the thin chance that it goes as coordinated, the journey to Proxima B will expect near 20 years, so, sensibly, it will be a seriously extended period of time before we can expect to confirm there is certain life on that planet. The DST has become flushed with deals on whether we are truly alone in this universe. Progress on this continues through the James Webb Telescope, which has discovered some incomprehensibly humanesque things far away from Earth that lead us closer to the response. Our mission for life beyond us has been unceasing throughout each human action, so much so that we have multitudes of media works and theories concerning this matter. Our wonder concerning our spot and significance in the universe has been consistent. It is ingrained inside us to constantly look for a mate. Despite the way in which practically identical we might be, we could get coherently closer to the answers we truly need. How are they actually the answers we are looking for, or are they just unsettling? Join us as we dismantle the most moderate discoveries in the space of systems and planets on the journey to find something we probably won't be able to see. Lights far away. Experts have found what could be the most important discovery in history. Back in 2021, when the James Webb Space Telescope was expected to launch, a particularly intriguing theoretical question was raised about the limits of our development. The inquiry was whether, in the future, our telescopes could perceive artificial light on another planet, for instance, Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was seen to be immaculately locked with a very enduring day side and night side, like our moon. A speculative imaginative overhaul for Proxima B could move power and energy from the day side to the night side utilizing photovoltaic cells that make power from starlight. In this manner, in a paper with Manisving as one of the researchers, it was shown that a sensational association of the day side by solar chargers could be connected with future telescopes. Since the JWST was also advanced, it would allow us to develop our journey for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did exactly that in 2024, using its higher resolution and greater capabilities, is significant. The JWST might have found the lights we were searching for, and maybe launched us into another surge of human action. By also, enormous, we should jump into the universe of planets and exoplanets to figure out how this was even possible. James Webb's mission investigates Proxima B and its mysteries. Since the beginning of recorded history, individuals have analyzed the chance of the universe, what we are, where we come from, and where we go. These are conventional yet incredibly gravely organized questions that mankind has endeavored to answer. When we acquired awareness in the era of great technological improvement, one might wonder whether we are any closer to answering these questions. If you somehow manage to ask a philosopher, he could say we are, at the present time, at level 0 of understanding ourselves in the universe. In any case, inquire a space expert the same question and watch him make the most of his energy as he rushes to tell you the latest discoveries people have made about the universe using their advanced gadgets. These instruments, though not given much thought by the general populace, are directly an impression of human advancement itself. We now have the world rapidly open, and it's time we push forward and get the universe readily accessible. One such method for doing so isn't entirely firmly established by inspectors and space experts. Through the advancement we tackle, an express formation of that advancement is now able for the new revelation of what might be light on another planet, light years away. Certainly, we're analyzing the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the customs of human endeavors into space to address some ever-present questions. Are we alone? Who's out there? Where do we begin, and where do we end? This infrared space science gadget has already started looking out for these questions, not traversing the truth that at first, you might get yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri B. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths could baffle you, but don't stress. This text will settle all your burning inquiries. Super-Earths are a class of planets that are larger than Earth but lighter than ice giants like Neptune and Uranus. They are truly one of a kind, and they can be made of gas, rock, or even a mix of both. Moreover, their sizes can range from twice the size of Earth to a few times its mass. Concerning Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby planetary system. The primary possible confirmation of an exoplanet was observed in 1917. Despite the fact that it ignited little interest, confirmation came in 1992 with the first confirmed discovery, which left informed authorities shocked. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These notable discoveries are surrounding an M-type star. To understand the M-type star, you need to consider the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the interconnecting area of the Sun, red dwarf stars are by far the most common type of star found in the Milky Way. They have extremely low luminosity, and since luminosity is one of our primary tools for planet discovery, red dwarf stars are challenging to see. These invisible stars have variable definitions and names depending on their temperatures and sizes. For instance, M-type stars are smaller individuals in the main sequence. Stars yield a greatest temperature of around 3000 K, hence getting their name. Worry in Proxima B, its mass is known to practically be unclear, from 1.07 Earths. Unusually, it simply requires 11.2 days to complete one circle of its star, diverged from our 365.25 days. You can measure the size of the star Proxima B is encompassing by considering the entirety of the electromagnetic reach. The star has a complete brilliance of as little as around 1.6% of that of the Sun. Other than in the obvious light reach, its brightness seems to reduce more. It just shines 5 to 6% of the Sun's quality, exuding a lot lesser measure of light energy diverged from the Sun. More than 85% of its created energy is infrared radiation, twirling around about 0.045 to 0.056 Australian dollars from its star. Proxima B's revelation was accounted for back in 2016. You could ask regarding the reason why Proxima B, with a considerable number of stars, planets, and universes, is of such interest. Well, there are a couple of reasons that add to the stargazer's advantage here. Explicitly, Proxima B is the nearest known star to our Sun by definition. Albeit 4.2 light-years is a significant number to us Earthlings. In the stupendous arrangement of the universe, it is a straightforward blip. So, for what reason is Proxima B, our closest known star, high up on the need list right now? It is part of the triple star system, also called Alpha Centauri, with Proxima's sparkle being very low. The framework itself shows up as conceivably one of the most splendid heavenly bodies in the night sky, just behind two others called Sirius and Canopus. Regardless, the most bewildering thing about Proxima B is that it could really be tenable, as it falls inside the Goldilocks zone. The possibilities surrounding the star are limitless, and subsequently, space experts have attempted the task of examining the profundities and cutoff points of the star's reasonability. Likely, that is where the James Webb Space Telescope, JWST, comes in. The four essential targets of the JWST are to look for light from the first stars and frameworks that formed in the universe after the Big Bang, center around the universe's headway and improvement, sort out star and planet development, and focus on planetary systems and the starting points of life. As the JWST proceeds with its evaluation of the said exoplanet, we draw nearer to the apex of these missions, from looking for exoplanets to looking for extraterrestrial life. So, what exactly is said? One could ask, taking into account that humans have forever been an inquisitive species, examining and getting into literally all that moves and doesn't move. It seems to make sense that a mission like this would appear. That's what on such a monstrous scale. Imagine, God has shaped an amazing, immense adventure. Regardless, with a sprinkle of gold, we are honored with being the ones looking for banners, all the more explicitly electromagnetic mutters from human advancements, past anything that we could ever imagine. SETI, short for the search for extraterrestrial intelligence, seems to be the world's most high-stakes round of Find the Stowaway, with our gathering as the searchers and the tremendous universe as the apparently boundless hiding spot. It is one of those fields where specialists are like high-level Sherlocks, tuned into radio waves and scouring for that inconspicuous signal. This cosmic sleuthing started during the 1960s. Frank Drake, an unquestionable astrophysicist, was among the first to detect radio transmission from the stars. It was a striking moment. At any rate, no untouchables appeared at his door. At least, not yet. Looking for something this gigantic takes patience and can navigate a seriously huge number of years. At times, much more. Not too many definitive extraterrestrial signs have been found. In any case, regardless of these undertakings, the energy keeps on growing as the James Webb Space Telescope continues to review exoplanets like Proxima B. A whole field of hope is emerging. Will we inadvertently track down confirmed affirmation of extraterrestrial life, or will we just experience stunning signs right outside our ability to comprehend, giving us more inquiries than answers? The discovery of life, in fact, could check the accompanying part of humanity's eternal interest, where curiosity and progress meet into one colossal, fortifying space story. So, we should keep looking, trusting to track down confirmation that we are not truly alone. The discovery of lights from distant exoplanets, like those perhaps seen on Proxima B, could be a gigantic push toward answering one of humankind's most critical requests. Are we alone in the universe? As the Webb Space Telescope keeps on assessing the skies, its discoveries will undoubtedly ignite more conversations, assessments, and perhaps challenges to our essential understanding of life, knowledge, and the idea of the universe. The consequences of these revelations grow quite far beyond straightforward interest. They carry the possibility to reshape our philosophical and scientific systems. For example, if we somehow end up confirming that Proxima B or another exoplanet harbors some sort of life, it would force us to reevaluate our position in the universe. Could life elsewhere develop in ways comparable to our own, or would it present a completely new kind of existence? Would it follow comparable notable ways, or would science and awareness challenge all that we are familiar with life on Earth? Whether or not we neglect to follow down direct confirmation of intelligent life, the simple reality that we could distinguish fake signals or lights from far-off worlds would still have huge implications. It would imply that intelligent human civilizations are out there, possibly capable of changing their environments in ways that are discernible from our vantage point. This would affirm that intelligent life isn't a unique case, but maybe an inescapable aftereffect of specific circumstances in the universe. At any rate, it's fundamental to remain grounded and vigilant regardless of such exposures. While the potential for finding life is exciting, it also raises the question: what happens next? How should we answer the affirmation of extraterrestrial life? Would we approach it with deference, interest, and logical tirelessness? Or would the revelations spark free-for-alls, apprehension, or even political battles? History has shown that humanity's responses to new discoveries, especially those that challenge deeply held convictions, can be eccentric. We should also consider the ethical parts of our curiosity. Assuming that we indeed find confirmation of life, especially intelligent life, what's the importance of our obligation as stewards of our own planet? What moral considerations should guide our interactions with various types of life, whether microbial or advanced? These are not questions that can be answered easily, and they will likely be a central piece of the conversation as we adventure further into the universe. By the way, the quest for life beyond Earth, driven by instruments like the James Webb Space Telescope, addresses an astonishing intersection of science, reasoning, and humankind's future.